Hello, Mr. Barry's geometry class. I'm taking a look at these addition rules. And I do have the addition rules up here. He may have presented them a little bit different. If you have a mutually exclusive events happening, probability of Y or Z happening, you take the probability of Y plus the probability of Z. If you have two non-mutually exclusive events happening, you have the probability of Y happening plus the probability of Z minus the probability of when they're both together. And so the first couple problems you have here, the first few problems you have here are like that. So when you have the probability of a GHS student may drive to school is 40% or 0.40. The probability of a GH student that catches a ride to school with a parent or a friend is 55%. The probability a GHS student likes to drive themselves to school and sometimes get a ride, so that's both of them together, is 36%. What is the probability that a randomly selected student arrives at school most days in a car, either driving themselves or riding with someone else? So you take those first two, add them together, minus when they are together, and you will get 59% or 0.59. Same thing for number two. I'm not going to read number two to you, but setting it up for you. It's the 20% plus the 46% minus 13%. I know I'm saying percentage. I'm just, in my mind, I'm moving that decimal two places to the right and putting a percent by it, but it's just easier to say that instead of 0.20. Number three, the probability a student is taking statistics at GHS is 35%. The probability a student is taking Bio 2 at GHS is 15%. The probability a student at GHS takes both Bio 2 and Stats is 10%. So what is the probability that a randomly selected student at GHS is taking Stats or Bio 2? So that would be the 35% plus the 15% minus that 10%, and you would get 40%. Using this chart here, we have the probability of marital status of males and females 18 years or older, or 18 years old or older in the United States in way back when, 2003. So I'm just going to do every other one to kind of get you started with this. Determine the probability that a randomly selected U.S. resident 18 years or older is male. So you take the males total out of the total, so it would just be 481 out of 1,000. Now you can simplify that fraction, use a simplifying fraction online, or simplify it yourself. Try B on your own. C, determine the probability that a randomly selected U.S. resident 18 years old or older is widowed or divorced. So you have the widowed is 66 out of the 1,000, and or divorced. So you're adding that to that 102 over 1,000. So your denominator stays the same, and just add the numerator. You can then simplify it and change it into a decimal, all that kind of good stuff. Okay, I'm going to move on down to E. I want you to try some of these on your own. Determine the probability that a randomly selected U.S. resident 18 years older is not widowed. So I took the 1,000 minus the 66, because that would be everybody else not widowed, over the 1,000. G, determine the probability that a randomly selected U.S. resident 18 years older is divorced or female. So the divorced, I have 102. Females total, I had 519. So it's going to be 102 plus 519 over 1,000. And lastly, determine the probability that a randomly selected U.S. resident 18 years older is divorced. And so you would just take divorced, and that would be 102 over the 1,000 total. Okay, I really hope this helped, and good luck with those ones that you're trying on your own.